our last two sorts of formulas that we're going to have for trigonometric sort of identities is going to be the product sum formula and the sum to product formula. So in this series, we're going to go through and we're just going to learn about how to use the product to sum formula and then also how to use the sum to product formulas. So let's start with the product to sum formulas. Okay, so basically, if you multiply a couple sine functions together that are different, so you have two different angles, x and y, then the ensuing formula would be 1/2 of the cosine of x minus y minus the cosine of x plus y, right? And then the rest would follow suit, right? Now, what I'm going to do is I'm going to prove one of these, okay? And then the rest of them can be proved in the exact same way just by using different formulas. So let's prove this one. Let's prove that sine x sine y is going to be equal to 1/2 cos x minus y minus cos x minus y. So in other words, we're proving this, right? So the first thing that we do is we take a look back all the way back to where we had our sum and difference formulas, right? And if we take a look at the sum and difference formulas, we had that the cosine of x minus y was equal to this, and the cosine of x, the cosine of x plus y was equal to this, and the cosine of x minus y was equal to this. And what we're going to do is we're just going to subtract those. Okay, so notice right here, if we want to prove this, we take x minus y and x plus y. So we're going to have cos of x minus y, and from that, we're going to subtract cos of x plus y. And so if we take a look at our formulas for those, cos of x minus y is cos plus sine sine. Okay, so that's going to be cos x cos y plus sine x sine y. And then we're going to subtract cos x plus y, and cos x plus y is cos minus sine sine. Okay, so that's going to be minus cos x cos y, and then minus sine x sine y. All right. Now, if you notice, what this is going to do is we end up with cos of x minus y minus cos of x plus y from subtracting these two. Over here, these are opposites and they cancel. And then when we have a negative, that's going to be a positive. And these two are like terms. So that would be equal to 2 sine x sine y, just by adding those together. And then finally, if we divide both sides by 2, those cancel out. And we're left with, I'll just pull the 1/2 out front, 1/2 cos x minus y minus cos x plus y. And that's to be equal to the product sine x sine y. Okay, and that's the proof of this formula. Sine x sine y equals 1/2 cos x minus y minus cos x plus y. All right, so that's where that formula comes from. All of the other ones can be proved in the exact same way, just by subtracting different sum and difference formulas. All right, so let's now see where we're going to use these formulas. All right, so problems where we can go through and express these as products of a sum or a difference. Okay, so sine 4x plus times sine 2x. Okay, so think of this as x and think of this as y in our formula, right? And we're just going to literally use the formula we just proved, the 1/2 cos x minus y minus cos x plus y. So this is going to be 1/2 of the quantity of cos of x minus y. So that's going to be 4x minus 2x minus the cosine of x plus y, which is going to be 4x plus 2x. And then we can now distribute the 1/2 to both of these terms. We can also combine like terms. And so we end up with 1/2 cos of 6x minus 1/2 cos of 2x. Okay, and that's literally it. Okay, so that's all we have to do. And you can imagine that this might be easier to work with because there's opportunities for us to use maybe like a double angle formula here. Or if we had like a triangle or something like that, now we could try to work on that triangle independently of these two. Okay. A second example, same exact thing, sine 5x cos 6x. So we go up top and we have, if we have sine of x cos of y, that's 1/2 sine x plus y plus sine x minus y. Okay, so think of this as x and think of this as y, right? And so we're going to have 1/2. As we said before, it's going to be sine x plus y plus sine x minus y. Okay, so sine of 5x plus 6x plus sine of 5x minus 6x. And then again, we can distribute. So this is going to be 1/2 sine of 11x plus 1/2 sine of negative x. All right. Now, one thing to remember is that the sine function is odd. Okay. And remember that the sine of negative x is equal to the opposite of the sine of x. And so what we could do is we could just take this negative and kind of factor it out, if you would, by using the odd sort of property. And so a final way that we could write this would be sine of 11x 1/2, or 1/2 sine of 11x minus 1/2 sine of x. All right. So both of these are fine. There's nothing wrong with either of them, but the second of the two is a little bit cleaner because anytime we can make that interior function positive, that usually works out well for us. Right. Last one we have here is cos cos. And again, think of 3x over 2 as x. Think of 5x over 2 as y. We go up to the top. We find that cos cos is 1/2 cos x minus y plus cos of x plus y. Right. So we're going to have 1/2 quantity cos x minus y, so that's 3x over 2 minus 5x over 2. And then if we look at our formula again, okay, plus cos x plus y. Okay, so that's going to be plus cosine of 3x over 2 plus 5x over 2. All right, and so we distribute, and that's going to give us 1/2 cos. We'd have negative 2x over 2, or just negative x, okay, when this simplifies. So again, just making sure we understand how that works, that would be negative 2x over 2, which is just going to be a negative x. And then here, this is going to be 8x over 2, or 4x. Okay, so 1/2 cos negative x plus 1/2 cos of 4x. And one last thing to remember is that the cosine function is even. Okay, so we probably remember this all the way back from one of the sections, but cosine of negative x is equal to cosine of just x, okay, because it's an even function. And so a little bit cleaner way to write this would be 1/2 cos of x plus 1/2 cos of 4x. Okay, all right. So that's literally all we have to do with these product to sum formulas. Okay. Now, what if we want to go in the opposite direction and get the sum to product? Okay, so that's what we're going to look at in the other video within this section.